We're talking about Atlas again, and this time, everything feels different. Months of silence are finally breaking as new data begins to pour in, revealing discoveries no one expected. For those just joining us, Atlas, officially known as 3I divided by Atlas, is the third interstellar object ever found passing through our solar system. Discovered in July 2025, it immediately sparked a race among scientists to study it before it disappears forever. And now, after its perilous journey behind the sun, Atlas has reemerged alive, transformed, and more mysterious than ever. When it slipped past perihelion, the closest point to the sun, on October 29th, no one could see it from Earth. It was lost in the glare of sunlight, invisible to even our most powerful ground-based telescopes. But space observatories didn't blink. Instruments like SOHO and GEO-19, designed to stare straight at the sun and block its blinding light, captured what might be the most extraordinary moment in Atlas's entire journey. And what they saw raised more questions than answers. At first, astronomers weren't sure if the comet would survive. The sun's corona was raging with plasma storms that could easily tear apart fragile bodies like this one. Some even believed Atlas might disintegrate completely, another cosmic ghost lost to fire. But when it emerged again from the far side of the sun, something incredible had happened. Between October 20th and 25th, just days before its closest approach, Atlas had brightened at a speed no one could explain. Its luminosity didn't increase gradually like a normal comet's. Instead, it skyrocketed in intensity following what scientists described as an inverse power of 7 relationship, a pattern never before observed. That surge made Atlas shine brighter than it ever had before, so bright that had you been watching from Mars, you could have seen it glittering like a blue flame against the sun's golden light. And then came the color shift. The comet, once faintly green, suddenly turned a vivid bluer even than the sun itself. This wasn't just an optical illusion. Spectral analysis showed clear evidence of volatile molecules, cyanide, ammonia, perhaps even other gases that glow in brilliant blue when exposed to sunlight. The discovery marked the third major color transformation since Atlas was first detected, from pale green to ghostly white, and now to deep electric blue. These rapid changes suggest Atlas is no ordinary object. It's unusually active, far more than most comets that visit our solar system. Every observation points to something volatile, ancient, and chemically complex stirring beneath its crust. Some scientists now believe Atlas could be a relic from the frozen outskirts of a long-vanished star system, a traveler cast adrift billions of years ago. Now awakening under the heat of our Sunday, images from the Very Large Telescope only deepened the mystery. They revealed a shifting, almost liquid-like halo of gas and dust stretching toward the sun, as though the star's magnetic field were shaping and pulling at the comet's tail directly. No model of ordinary comet behavior fits this. Could Atlas be interacting with the sun's magnetic field in a new, unknown way? Or is there something within its composition that reacts differently to solar radiation? That question is now at the forefront of international research, with teams across the globe analyzing every frame, every wavelength. Meanwhile, data from the James Webb Space Telescope offered an entirely new perspective. In the infrared, Webb's sensors picked up chemical fingerprints that told a story billions of years in the making. The surface of Atlas, it turns out, has been bombarded by cosmic radiation since before our sun was even born. Over eons, high-energy particles from across the galaxy slammed into it, rearranging molecules and carving a hardened crust, an ancient, irradiated shell about 15 to 20 meters thick. To scientists, That crust is like a time capsule, a cosmic record of every impact, every ray, every transformation the object has endured. Each grain of dust might hold information about the galaxy's earliest chemistry, long before our solar system existed. If humans could ever land on Atlas, especially when it drifts far from the sun's heat, they wouldn't be standing on ice. They'd be standing on history itself. This discovery changes how scientists view comets entirely. For decades, researchers believed comets were untouched relics of the early solar system, pristine samples of ancient matter. But Atlas challenges that idea. Its crust, far from pristine, is scarred and chemically altered by billions of years of radiation exposure. What we see today isn't a frozen relic, but a living archive, one that's been rewritten countless times by the universe itself. And yet, deep beneath that surface, untouched layers may still exist. Scientists suspect there could be ancient ice hidden far below material from Atlas's birthplace, frozen before any star system formed. If the sun's heat cracks the outer shell enough during this passage, it might expose those primordial layers for the first time in history, giving us a glimpse of pure, unaltered matter from another star. One discovery, in particular, adds a fascinating new twist. Atlas appears to contain more nickel than any other known comet. Though the finding remains under review, it could indicate that different star systems produce comets with unique chemical signatures, a sort of cosmic fingerprint of their parent stars. If true, it means we could one day trace the origins of interstellar objects back to their birthplaces, reconstructing the chemical family trees of entire stellar neighborhoods. And so, Atlas becomes more than just a comet passing through our solar system. It's a messenger carrying the memory of worlds that may no longer exist. Each molecule, each wisp of gas released into the void, tells a story older than our Sunday. The challenge now is decoding it. Every telescope pointed at the sky, from Hubble to Webb, from ground observatories to orbiting instruments, is gathering data, frame by frame, in a global collaboration unlike anything before. The story of Atlas isn't just about astronomy. It's about origins, about how the building blocks of planets, of life, may have traveled between stars long before Earth was born. For all we know, the very atoms that make up our oceans, our air, our DNA, may once have belonged to an object just like this one, passing silently through space, carrying the seeds of something greater. And now, for the first time in human history, we have a chance to see one up close. But this is only the beginning. The days after perihelion brought new surprises and even deeper mysteries. What scientists found next would challenge not just how we see comets, but how we understand the creation of planets themselves. In the weeks following its passage around the sun, Atlas began to reveal an even deeper story, one that stretched across billions of years of cosmic history. As the comet reappeared from behind the solar glare, telescopes around the world turned toward it, gathering every possible photon before it vanished again into the dark. What they found wasn't just fascinating, it was revolutionary. For decades, scientists have wondered how planets form. The traditional model says that dust grains orbiting a young star collide and stick together, slowly building larger and larger rocks until they eventually form planets. But there's a problem with that idea, something astronomers call the meter barrier. Once particles grow to about 1 meter in size, collisions don't make them grow bigger. Instead, they tend to bounce apart or break into smaller pieces. It's like trying to build a planet out of marbles that refuse to stick. So if that process stops at 1 meter, how do worlds ever get bigger than that? How do entire planets come into being? Atlas, it turns out, might hold the answer. A new theory has started to emerge among planetary scientists. It suggests that interstellar comets like Atlas, ancient, wandering bodies ejected from other star systems, could serve as the missing link in planetary formation. These travelers, forged in the cold outskirts of distant suns, are made of dense, stable materials. When they drift close enough to a young star, surrounded by a disk of gas and dust, the star's gravity might capture them. Once trapped, the comet could act as a seed core, a solid foundation around which new matter gathers. Instead of starting from fragile dust, a planetary system could begin with something like Atlas, a ready-made nucleus capable of attracting gas, rock, and ice. That single event might bypass the meter barrier entirely, allowing planets to grow far more quickly and efficiently. If true, the implications are extraordinary. It means the formation of planets may not be a closed process limited to one solar system. Instead, it could depend on an exchange between stars, a cosmic sharing of building blocks. Comets from long-dead systems might wander into new ones, seeding them with the material needed to form new worlds. Planetary birth, in that sense, becomes a story of interstellar cooperation, not isolation. This could also explain why gas giants like Jupiter and Saturn, massive planets made mostly of hydrogen and helium, often form around larger stars. Their powerful gravity would make them especially good at capturing passing interstellar bodies. Each captured comet might help build the core of a new world, one pebble, one frozen fragment at a time. It's a vision that connects everything, a network of creation linking distant stars across the galaxy. And right now, Atlas is helping scientists understand how that network might work. Every molecule on its surface, every dust grain escaping from its tail, carries evidence of chemistry that predates our Sunday. But the mystery doesn't stop there. Observations from the James Webb Space Telescope and other instruments have confirmed something else. The outer layers of Atlas are chemically transformed. The intense radiation it endured during its long interstellar voyage has altered its molecules in ways never seen before. Carbon monoxide slowly converted into carbon dioxide, and complex organic compounds may have emerged from the chaos of radiation bombardment. This process, called cosmic reprocessing, means that the gases escaping from Atlas today aren't the same as those it was born with. Over billions of years, cosmic rays and high-energy particles have rewritten its chemistry. That revelation forces astronomers to rethink what comets truly are. They're not static fossils frozen in time. They're evolving entities shaped by their journeys through the galaxy. And that changes everything we thought we knew about the origin of life. If cosmic radiation can transform simple molecules into more complex organic compounds, then every comet wandering between the stars could be carrying the ingredients of life, or even the precursors of DNA itself. This idea gives new strength to an old but powerful theory, panspermia. The concept that life, or at least the seeds of it, can spread from one world to another through space, carried by objects like Atlas. Imagine that billions of years ago, comets from other star systems seeded our own solar nebula with organic material. As Earth formed, those compounds rained down onto the young planet, merging with its oceans and atmosphere to spark chemistry that would eventually become life. If that's true, then life on Earth may not have started here at all, but in the deep, cold silence between stars. Atlas, with its heavily irradiated crust and ancient chemical record, might be a direct witness to that process. It could be carrying the same kinds of molecules that once seeded life itself, When scientists study its light spectra, they're not just measuring gases, they're reading a story about how the building blocks of biology might have traveled across the galaxy long before our species existed. Back on Earth, the story of Atlas has captivated more than just astronomers. Observatories across both hemispheres are now competing to capture the most detailed images before the comet fades. The Lowell Discovery Telescope has already confirmed that Atlas survived its perilous encounter with the Sun, intact and still active. Its tail, faint but visible through small telescopes, now stretches northward in the pre-dawn sky, a glowing line connecting humanity to another star system. For amateur observers, it's a chance to look directly at something older than our world, something that began its journey long before the Earth took shape. For professionals, it's a scientific opportunity that may never come again. Every telescope, Hubble, Webb, the European Very Large Telescope, is part of a coordinated effort to map Atlas in as much detail as possible. Missions like NASA's Lucy and Psyche, which happen to be exploring nearby regions of space, have been redirected to gather auxiliary data on the comet's path and environment. Together, these projects form one of the most ambitious observational campaigns ever conducted on a single object. All of this is building toward one moment, the 19th of December 2025. That's when Atlas will make its closest approach to Earth. For a brief time, the comet will shine brighter, revealing the fine structure of its nucleus and tail. Scientists will analyze the reflected sunlight, searching for traces of rare gases, metals, and organic molecules. The Clipper mission, already in position to intersect the comet's plasma tail, will attempt to capture microscopic dust and charged particles, samples that could reveal how comets interact with the solar wind and what kinds of materials they carry. For the scientific community, this is a once-in-a-lifetime chance to study an interstellar visitor before it disappears forever. By March 2026, Atlas will swing past Jupiter, then accelerate into the darkness beyond Neptune. After that, it will be gone, leaving the solar system at speed so high that it may never return. Every night until then, telescopes around the world will follow it. Every hour brings new data, new light curves, new mysteries. And as the comet races toward the edge of the solar system, one truth becomes clearer than ever. We are witnessing something extraordinary, not just a comet, but a messenger from another world, carrying within it the story of creation itself. As Atlas continues its long arc away from the Sun, the story is far from over. The comet that once blazed with blue fire now glides silently through the darkness, cooling, dimming, yet still pulsing with secrets. Every image, every spectrum recorded from Earth and space telescopes adds a new fragment to its mystery. Scientists are racing against time, knowing that once Atlas passes beyond Jupiter's orbit, it will fade into the void, perhaps never to be seen again. What remains is a desperate effort to understand what this object truly is and what it means for our place in the universe. In early November, a new analysis from the James Webb Space Telescope confirmed that the comet's crust, the dense 15-20 meter thick shell formed over billions of years of radiation, isn't just scarred matter. It's chemically alive. Layer upon layer has been reshaped by cosmic storms, by bursts of high-energy particles, by the invisible rain of galactic rays that have rewritten its molecular structure countless times. Inside that crust, there are traces of complex carbon chains, possible precursors to amino acids, the chemical language of life. No one expected to find such signals. It means that radiation, long thought to destroy fragile molecules, might also create them, forging the ingredients of biology in the emptiest places between the stars. Every impact, every cosmic flash leaves behind something new, something more complex. Over billions of years, comets like Atlas become not just relics, but laboratories, places where chemistry slowly crosses the threshold into life. This revelation has reignited an old question that humanity has asked for centuries. Are we alone? Or are we simply one outcome of a process written into the physics of the universe itself? If comets can synthesize organic compounds in deep space, then life may not be an accident confined to one blue planet. It could be a universal pattern, a phenomenon that emerges wherever matter, time, and radiation meet. And so, Atlas becomes a messenger not only from another star system, but from another age, carrying within it the possibility that the seeds of life drift endlessly through the cosmos, waiting for a world warm enough to awaken them. Back on Earth, the night sky has turned into a stage. Astronomers across the northern hemisphere now track Atlas nightly as it approaches its closest pass to our planet. In the hours before dawn, it can be seen as a faint streak stretching upward like a spectral ribbon of light. To the naked eye, it is small and distant, but through the lens of a telescope, it looks alive, breathing, changing, shimmering. For many who watch, it's not just a scientific moment, but an emotional one. To witness a visitor from another star, to know that it has traveled for billions of years just to cross our path, it's a reminder of how connected everything in the universe truly is. Every atom in our bodies was once part of something ancient, perhaps even part of a comet like this, drifting through space before the Earth itself existed. As Atlas nears its December 19 close approach, global observatories are preparing for the final campaign of observations. The data gathered during this narrow window could answer the most important questions yet. What lies beneath that irradiated crust? Are there pockets of ancient ice untouched since the birth of another star? Could those buried layers hold the pure chemical fingerprints of its origin? For the Clipper mission team, the stakes are enormous. If the spacecraft successfully crosses Atlas's plasma tail and collects microscopic samples, humanity could soon hold in its laboratories grains of matter that formed before our sun fragments from another system, from another time. Those particles might tell us what kind of chemistry shaped the early galaxy, or even whether the materials that once seeded life on Earth are still drifting between the stars today. By January 2026, Atlas will begin to fade rapidly. Its path will carry it outward past Jupiter, where sunlight can no longer reach its frozen surface. The comet's activity will slow, its jets of vapor will quiet, and the blue glow that once mesmerized astronomers will disappear into blackness. From there, it will continue on a silent trajectory into the deep interstellar dark, becoming once again what it has always been, a wanderer between stars. Yet the legacy of this encounter will not fade. Already, Atlas has forced scientists to rewrite major parts of cometary science. The idea that comets are unaltered remnants of creation has fallen away. We now know that they evolve, that their chemistry changes, that their surfaces bear the marks of time and radiation. More importantly, Atlas has shown us that the story of life and planets may be far more interconnected than we ever imagined. Across universities and observatories, teams are still analyzing terabytes of data. Spectrographs, temperature profiles, ion traces, dust morphology, magnetic field readings. Each analysis reveals new subtleties, fluctuations in brightness that don't match any model, jets of gas emerging from unexpected angles, and hints of compounds that shouldn't exist in such abundance. Some researchers have even proposed that Atlas's strange behavior, its dramatic brightening, its 3 distinct color shifts, and its resistance to fragmentation could point to physical processes humanity has never directly observed. There might be chemical reactions happening within its crust that involve exotic molecules formed under interstellar radiation, reactions that briefly release bursts of light as they break apart. Others believe the comet's structure itself could be unusual, with magnetic fields trapped inside ancient ice, interacting with the sun's own magnetism in unpredictable ways. Whatever the truth, Atlas has become something more than a scientific object. It's a symbol of curiosity, a testament to how much we still don't know about the universe we inhabit. As one astronomer recently put it, studying Atlas demands humility. It reminds us that we are still beginners, looking out at an ancient cosmos. Not every mystery will be solved. Some answers may remain hidden forever, locked beneath that frozen crust as the comet drifts into eternity. But even as it leaves, Atlas leaves behind something precious: knowledge, perspective, wonder. It reminds us that the universe is not a static place. It's alive with motion, with exchange, with transformation. Worlds give birth to comets. Comets carry the ingredients of life, and those ingredients may one day form new worlds again. It's a cycle written in starlight and dust. And somewhere out there, perhaps in another solar system, another civilization might be looking up at their night sky, watching their own version of Atlas pass by, wondering, just as we do, if they are alone. By March 2026, the comet will vanish beyond the reach of our instruments. The last photons it reflects will arrive on our sensors, the final data points added to an archive that will be studied for generations. Long after its light fades, the questions it inspired will continue to guide us, questions about the nature of creation, the origins of life, and the invisible threads that tie one star system to another. In the end, that may be Atlas's greatest legacy. Not just the science it revealed, but the awe it restored, the realization that we are part of something vast, ancient, and still unfolding. When it finally disappears into the cold beyond Jupiter's orbit, Atlas will take with it a story billions of years in the making. A story about fire and ice, radiation and time, and the fragile possibility that life itself might be a universal consequence of the stars. And as we watch it fade, we are reminded that even the briefest visitors can change how we see the universe forever. The mystery of Atlas isn't ending. It's only just begun out there in the endless dark between the stars.